Equivalent ratios. So a ratio is basically defined as a multiplicative comparison of two things. And it's got this long, complicated word, multiplicative, but it means basically a comparison by multiplication of two different items, two different things. And you'll see that it can look a lot like fractions, but what you're really doing is comparing two different things. So let's look at this. We've got some baseball bats and then footballs, and we're going to make a comparison. We're going to write a ratio for these two. So if we look at this correctly, there are 5 baseball bats to 3 footballs. And like I said, it looks kind of like a fraction, an improper fraction. So that's one way you can write a ratio, 5 baseball bats to 3 footballs. There are 2 other ways that you can write a ratio, or 3 total ways. The other 2 ways look like this. You can do a 5 over 3 that looks like a fraction. You can put a 5 and then a colon, which is like the 2 dots, and then to 3. And the third way is you can just write 5, 2, 3. So those are the 3 ways you can represent a ratio. You can write it as a fraction like that with kind of a numerator denominator, keeping in mind it's still a ratio. You can put the colon right over there, kind of like you would if you were writing down the time, 5 to 3, or just write it out, 5 to 3, just like that. So a ratio, comparison of 2 different things. So let's look at this right over here. You got some basketball shoes, some Jordans, and I've got some sandals. So we're looking at the ratio of the shoes to the sandals. So as we look at that over here, it looks like there are 5 of the Jordans and 1, 2, 3, 4, 5, 6, 7 of the sandals. So that's a 5 to 7 ratio that I'm showing right there. Again, the other ways that I can write this, 5 colon 7 or 5 to 7. So that's my ratio that I have right there. Now, what if I take this 5 to 7 ratio, write that a little bit neater, and come up with a similar ratio, or what we might call an equivalent ratio. So if I looked at this and I said, well, if I had 5 Jordans or 5 basketball shoes and 7 sandals, would that be the same ratio, the same comparison, is having 15 Jordans and 21 sandals? Think about that for a second. Is that an equivalent ratio? Now, if you're thinking of equivalent fractions, you're kind of on the right track. If I look at a comparison here between these and these, kind of what looked like numerator denominator, if you multiply each of these by 3, then I believe this equals 15 and this equals 21. So if I had one ratio that was a 5 to 7, 5 basketball shoes to 7 sandals, it would be the same ratio, a equivalent ratio would be 15 basketball shoes to 21 sandals. There are a lot of different equivalent ratios we could come up. Another one would have been 10 14ths if you just multiplied them by 2 each. 10 basketball shoes and 14 sandals. You can also get a ratio sometimes that's less than the original ratio that you start with by dividing. So even though these numbers have changed, they've gotten greater, the ratio, the comparison between the two values is still the same. So let's try this. So again, definition, equivalent ratio, a ratio that shows the same exact comparison with different numbers, like equivalent fractions. So again, when you guys are thinking of like a 3/4, which is a ratio, can be a 3 to 4 ratio. Well, what would be an equivalent ratio to that? Could we say, like, I don't know, to be quick about it, 6 to 8 could be an equivalent ratio if we just multiplied by 2. If we did by 3, we could say 9 to 12. So you can see where we're going with this, how we can create equivalent ratios. So let's do this real quick. We've got these vampires and the Frankensteins, and if I want to come up with some equivalent ratios for this, so first off, I can just write my original ratio. This looks like I have 6 of the vampires, 4 of the Frankenstein, so it looks like a 6:4 ratio right there. So equivalent ratios that I can come up with. If I multiply up, I could come up, if I multiply by 4, say, I could get 24/16. What if I got this ratio, a 3:2? Does that seem plausible to have a 3:2? Well, it does, because actually, yes, you can get a ratio with smaller numbers. It's just showing the comparison between the two. If we divided both of these by 2, I'd get 3 and I'd get 2, and a 3:2 ratio. If I just had 3 of these vampires right here and 2, I'm basically cutting my ratio in half, but it's the same ratio. I'm cutting my numbers in half, sorry, but it's the same ratio, same comparison between these two items. So you can see how we can come up with equivalent ratios here. Last one I want you to try on your own. So I want you to come up with 3 equivalent ratios for 10:12, a 10:12 ratio. Remember the 3 ways that we can write a ratio. It's one way is written right over here. Remember, we can write it kind of in what looks like fraction form as another way. And then finally, that last way is writing it as 10:12. So I want you to pause the video and come up with 3 equivalent ratios for 10:12. You can unpause it. I'll put a couple of them down and see if any of them match up. Go ahead. Okay, hopefully you've got some equivalent ratios. One of the strategies I think is most helpful that I'm going to ask you to try is writing down your ratio and then first kind of simplifying it to its lowest terms, like if we did this with a fraction. So if we figured out, if we divided this thing by the lowest, basically the lowest number that went into it, that lowest denominator, we could get 2, which would go into is 5 times, and would go into this 6 times if we divide it by 2. So 5/6 is one equivalent ratio. And now from here, when I get this its simplest value, I can basically create a pattern. I know if I just multiply by 2, the top number and the bottom number by 2, or by 3, or by 4, or by 6, as long as I multiply them by the same thing, I'm going to get equivalent ratios, and I'm basically going to get a continuing pattern of them. So 10/12 is our original one. From there I could have gotten 15/18 if I multiplied by 3. If I multiplied by 4, I can get 20/24. If I multiplied by 5, 5 times 5 is 25. 5 times 6 is 30. One more, multiply by 6, 5 times 6 is 30, 6 times 6 is 36. So I'll stop there, but you can see how we can come up with equivalent ratios and that comparison between two values when we look at ratios.